A project by definition is a set of tasks. So the first phase in a project analysis is to illustrate those tasks. Let's look. Epic Scenic Studios must build a stage and fabric backdrop for a trade show display at the San Diego Convention Center. This job, meaning this project, consists of 9 tasks. Oh, and here's the description. The tasks have an abbreviation, a description, a duration, each one takes a certain number of days, and some precedence relationships. Now, what's requested here? What does this project look like as an AON network? AON stands for activity on the node, meaning node is a shape, the activities, the individual tasks are shapes in our illustration. Oh, all right, so what we need to do is draw from this data right here an AON network. I have borrowed a pencil. Okay, first tip in drawing project networks, try to draw in something that you can erase. Why? Because there's no way when you're drawing a network to know if that's exactly how you want to arrange the tasks, even as you're working on the network. It's just really helpful to be able to erase. Okay, so second tip, drawing an AON network. What do you do first? Draw the start of the project. Remember, this is an illustration of a project. All projects have a start. Or another way to say this is, I have drawn the starting node. What is this? This is simply a symbol that represents we started. Okay, now what's next? Scan the task data. These are the individual activities up here. What are you looking for? You are looking for activities that don't have any immediate predecessors. Why? Because by definition, those are tasks that you can get started on right away. It means there's nothing that needs to be done before these tasks are started. So for this project for the San Diego Convention Center, right, create the technical drawings and purchase and dye the fabric. If you're looking for something to do, you could start on that right now. Oh, okay. Add them to the network. Those are 2 tasks that are at the beginning. So I'm just going to, now I'm going to draw symbols that represent that work. Again, we're using rectangles here. From the start, you're looking for something to do. You could do A. Now notice I drew or wrote the abbreviation in the upper left-hand corner. There's a reason for that later. It's handy. It's a handy format. And down here, another symbol that represents B, purchase and dye the fabric. If you are looking for something to do at the start, you could do that right away. Oh, as long as I am working on these, here's something that's handy. It's not necessarily part of the network, but we'll be glad we did this later on. Each task, like A, has a certain duration. The technical drawings that's estimated will take 1 day. I'm jotting that fact below the label in the lower left-hand corner. And the same thing with B, purchase and dye the fabric, 3 days. I'm just copying that onto the network. Okay, that'll be useful later. Oh, all right, now we're drawing an AON network. We're finished when all the tasks that were listed are on the network. Right now we have 2. We have A and B taken care of, like check them off the list. Now what do? Now we scan the data for anybody who, and what am I scanning? I'm scanning the immediate predecessors for anybody who has A or B as an immediate predecessor. And I noticed right away that task C, build the stage, has A, finish the drawings, as an immediate predecessor. Great, what do I do with that? Add C. Here's C, build the stage, and here's how we illustrate the fact that you have to complete the drawings. That was A, before you build the stage. That's C. Okay, and I'm going to jot the duration on there. That's 4 days worth of work. There, C's done. Oh, I noticed that D has B. D, sew fabric and frame backdrop, has B as an immediate predecessor. Here's B, right? So I will draw D. It can be started as soon as B is finished. And D, what was it? 2 days worth of work. Okay, so then that one's done. Oh, E. E, sometimes it helps to have a ruler. E has A as an immediate predecessor, just like, what was it, C did? No problem, I know how to draw that. Here's task E, coming after A, so to speak, connected by an arrow. E is 1 day worth of work. Great, okay, E's done. Now, who's this? This is F, paint the stage. Okay, it has C as an immediate predecessor. C was build the stage, that makes sense. You have to complete that before you go on and do F, paint the stage. And then F is 2 days worth of work, the painting. Oh, great, that one's done. So I'm motoring along on this list, and I say, oh, all right, the rest of these don't have A or B or C, but who can we add? G has D and F. So I want to draw a symbol that represents G, the trial assembly, and I want to connect D and F to it. That's what that means right there. And here's a problem. Actually, I see a problem right away, which is, this is the type of problem, this happens naturally, right? This is why we draw in pencil. Okay, what had I said? I said I wanted to draw, for instance, a symbol where I can connect D and F. My problem is E. You say, well, what's wrong with E? See how E is sticking out here? If I draw the symbol for G here and I connect these two, I kind of box E in, right? I can't really connect anything else to it without starting to cross arrows. It's just bad. It's just going to make the network confusing. There's an easy way to fix this. Now I see it in hindsight, and that's why I have a pencil. You know what? Let's do this. I'm sorry I put F there. I'm erasing it. Why? Because I'm sorry I made the top one C and the bottom one E. Why don't we do this? Let's make the top one E and the bottom one C, right? That doesn't change the meaning of what's going on here. It's still consistent with the data, so that F has to move here. And then let me restore the data. E was 1 day, C building the stage was pretty long, 4 days, and F painting the stage was 2 days. Ah, there's a good repair. There's a good repair. Why did I make that repair? Because I want to draw G. I want to draw G someplace convenient. Where I can connect F and D without boxing anybody else in, basically. Okay, and at the trial assembly, only 1 day. Oh, good. Now, oh, and then H, that's pretty straightforward. It has G as an immediate predecessor, so I just say, okay. When the trial assembly is over, you would disassemble, that makes sense. You'd go on to H, 1 day. And then there's only one left, and that's I, assemble at the convention center, touch up paint and adjust lighting, and it has E and H as immediate predecessors. Might be logical to put it here. I, one long arc, E has to be done, and H has to be done. I is only 1 day worth of work. And then at that point, I think that, yes, I have everybody in that table. Now on the diagram, the diagram's not exactly finished yet. There's one, it's just sort of like finishing touch to it. Just as every project, not just this one, but every project has one start, you know, you draw a starting node and you start building it. Every project naturally comes to a finish. There is a distinct point in time, right, that is the finish of the project. We should draw that. We should draw the finish. So, okay, well, it would be over here, right? Yes, it would be over here. And we want to connect every node, every square, if you will, every task that has arrows pointing at it, but no arrows leading away from it. So I is obviously something that occurs at the finish because it fits that description. Everything else, I think if you do a check, will have arrows pointing at it, but also there's a way to, another way to think about it, you're checking that in each case, if you go into a box, there's a way to escape it. If there's not a way to escape it, then connect it to the finish. At the point that you've done, you should check, because it's not always just one last task to the right that needs to be connected to the finish. Just do that check. In this case, it is only task I that needs to be connected to the finish. Do that, connect everybody up. We have a start, we have a finish, and we have drawn each of the tasks that's on the table. We have our activity on the ARC network.